Today we are going to talk about input-output organization. In input-output organization, we are going to discuss about input-output interface and asynchronous data transfer. Next, coming to the input-output organization, it provides the input-output organization of a computer provides an effective mode of communication between the central system and the outside environment. So here the central system is nothing but your internal storage devices, whereas outside environment is nothing but your external storage devices. So the input-output interface provides an efficient mode of transferring your information between the internal storage as well as your external storage. So internal storage includes the CPU and the memory, whereas the external storage includes the peripheral devices. So peripheral devices are nothing but your magnetic disks, magnetic tapes, keyboards, printer. So all the input-output devices are considered as a peripheral devices. Next, coming to the input-output interface, why do we need an interface for our input-output system? So there are major, if you see the CPU and the peripheral devices, there are different types of differences that exist between the CPU and the peripherals, which requires the need of synchronization between the CPU and the peripherals. So the first and the foremost difference is that the peripheral devices are electromechanical or electromagnetic devices, whereas coming to the CPU or a memory, they are electronic devices. So the IO devices are relatively very slow, whereas the CPU is considered as one of the fastest device. Next, coming to the other difference, the data format. The data format in case of IO devices is in the form of bytes, whereas in CPU, the CPU is going to execute the instructions in the form of words. That is one of a difference. And the next difference is the mode of transfer. Those IO devices are going to transfer the information. For example, if you consider a keyboard, the keyboard is going to transfer one character at a time. So the character is nothing but a ASCII value, it is considered as 1 bit. So character by character, the keyboard is going to transfer the data. So it is done, and that transfer is done in a serial manner. Whereas coming to the CPU, it executes the instructions in a parallel manner, which means nothing but multiple instructions simultaneously. You can execute, the CPU is capable of executing multiple instructions simultaneously, whereas IO devices are going to transfer the data in a serial manner. And so because of these differences, we require some synchronization mechanism to be applicable between the CPU and the peripheral devices, and that is taken care by means of an input-output interface. So this is a diagram which explains you about the input-output bus and the interface module. If you see here, the processor is nothing but as your CPU, and these are nothing but your input-output devices. So here you have a keyboard, printer, magnetic disk and magnetic tapes as input-output devices, and the CPU. So how does the connection is established between the IO bus and the input-output devices? So if you see this is said to be called as an interface, input-output interface. This interface acts as an intermediary between your CPU and the peripheral devices in order to provide a synchronization between them. So in the interface, there exist two types of registers. One is a status register and one is a buffer register. So whenever an information has to be transferred from the CPU to the peripheral device, the buffer register of interface circuit will store that particular information from the processor into its buffer before transferring that particular information to your peripheral device. Similarly, we also have one more register called status register. The status register is used in order to find the status of the particular peripheral device, whether the peripheral device is idle or it is busy. So that is determined by looking at the status bits that are present in the status bit register of an interface circuit. Okay. So if you see here, each and every peripheral device has an interface attached to it, where each interface internally contains a status register and a buffer register, where the buffer register is used to store the information from the bus into its buffer before forwarding it to the corresponding peripheral device, and the status register is used to it contains the status bits which are required in order to know the status of that particular peripheral device by looking at the status bits of the status register. So each and every device have its own interface module. So if you see the connection between the CPU and the interface, they are connected by means of an input-output bus, and this input-output bus is established using three lines: data line, address line and control line. So the interface module of all the peripheral devices are connected to the input output bus to all the 3 lines of the input output bus. So next we are going to talk about this is the each interface of an IO device consists of a buffer register and a status register. As I already told you, the buffer register is used to store your data or the information from the IO bus and place it into the buffer before being transferring it to the corresponding peripheral device. Similarly, the status register is used in order to know the status of that particular peripheral device. So the CPU is connected to the interface by means of a bus. Next we are going to talk about IO bus. As I already showed you in the previous figure, there are 3 types of lines which are present in IO bus. So there are 3 lines: address line, data line and control line. So we will know about what are these 3 lines and what is the use of these 3 lines of the IO bus. Next slide. So it has 3 lines: address line, control line and the data line. The address line, the use of an address line in IO bus is nothing but, for example, consider the CPU wants to access one of a peripheral device, consider a printer or any other printer or a keyboard. So in that case, to access any IO device, the CPU places the address of that particular peripheral device onto the address line. So onto the address line of the IO bus. So, and each and every interface module of the peripheral device contains a decoder, and the decoder is going to decode that particular address which is present on the address line, and whenever it finds that the address which is present on the address line is its own address, it will enable that particular peripheral, whereas other peripheral lines will be disabled. So that is the use of an address line of an IO bus. Next, coming to the control line specifies what type of an operation the CPU wants to perform, whether it wants to perform a read operation on the peripheral device or the write operation. That is specified by means of a control line. Next, coming to the data line. So depending upon the type of operation specified on the control line, the data that has to be read or returned to the peripheral device, it will be placed onto the data line of the IO bus. So these are the use of 3 lines. So next, coming to the IO commands, each and every peripheral device will receive 4 types of commands. There are control command, status command, data input command and data output command. So each and every peripheral device of a computer, it can receive any 4 of these commands, which are control, status, data input and data output. Coming to the control command of any peripheral device, if the particular interface of the peripheral device receives a control command, it means that particular command is used to activate the peripheral device and tell what is the operation that the particular device has to do. So that is a use of a control command of received by an interface of the particular peripheral. Next, coming to the status command. So the status command is used to test various status associated with an IO module and its peripherals. So in order to check the status of any peripheral device, whether it is idle or busy, the status command, whenever it receives a status command, that particular interface module of the peripheral device will check the status of that particular peripheral. Next, coming to the data input command. The data input command, it causes the IO module to obtain any item of data from the peripheral and place it into the buffer register. Consider a keyboard as a peripheral device. In case of a data input command, that particular interface module will take the input from the keyboard and place it into its buffer register whenever it receives the data input command. Data output command is nothing but the IO module will receive the information from the IO bus and places it into the buffer register before transferring that particular information onto the peripheral device. This example is, for example, if you take a printer. So if you want to print something, the CPU will place the information on the IO bus, where the interface unit of the particular printer peripheral will take the information from the bus and place it into the buffer register before transferring that information to the printer. Okay, so these are the 4 types of IO commands where each and every interface module receives. So next, coming to the accessing the memory and IO devices. Generally CPU can access both the memory as well as the IO devices using 2 types of approaches. First one is the memory mapped IO and the second one is isolated IO. So a CPU can access the memory, any memory unit of your computer as well as the IO devices using these two approaches of memory mapped IO and isolated IO. Next. So this is a diagram for your isolated IO. So in case of an isolated IO, if you identify, as the name implies, isolated IO, which means that the memory space and IO device space are different, they are isolated, the address space are isolated. So that does not have a common address space, the memory has its own own address space, whereas your IO devices have their own address space. But the address bus and data bus are common for both the memory devices as well as the IO devices. But coming to the control line, the read and write lines, they are separate for the memory unit as well as the IO devices. They have their own read and write inputs for the memory and read and write inputs for the IO devices. Coming to performing a read and write operations of the memory devices, they can be performed in case of isolated IO, the memory can perform a read and write operations using load and store instructions, or it can also be performed using move instruction. So coming to the IO devices, the read and write operations can be performed by using in and out instructions. But coming to the address bus and data bus, they are common for both the memory and IO devices. The control lines are only different for both them. That is the reason the address space is separated for both the devices. So that is the reason it is called as an isolated IO. Next, coming to the memory mapped IO. Memory mapped IO, if you take the memory mapped IO, the address space is common for both the memory devices as well as the IO devices. Both of them share the same address space, and the address bus, data bus and control bus are common for all for memory as well as the IO devices. So that is the reason it is called as a memory mapped IO. Next, coming to the advantages and disadvantages of isolated IO. So coming to the advantages of isolated IO, large IO address space, because larger IO address space compared to the memory address space, in case of memory mapped IO, we have a same address space shared between memory and IO devices, but here they are separated from each other and they have their own address space which is very large compared to the memory mapped IO. Next, coming to the flexibility. Flexibility in the sense, in case of IO memory, if you want to add a new IO device to the to it, then it gives more flexibility. It does not have any effect on the memory IO. So it provides great flexibility as IO devices can be added or removed from the system. And next, improved reliability. Improved reliability means that if any device, any of the IO device fails, it does not affect the memory system, because the memory and IO devices have their own address space. So the reliability means that whenever a device fails, it does not affect the other devices or other memory. So it provides improved reliability. Next, coming to the disadvantages of isolated IO, slower IO operations. It performs operations very slow compared to the memory mapped IO, because it requires the use of specialized instructions. So in order to implement a isolated IO, we need to require some specialized instructions, implement some specialized instructions which require complex programming. So that instructions requires slower, they take more amount of time to execute, which results in slower IO operations. Next, more complex programming. As I already told you, it requires the use of some specialized instructions. Those specialized instructions can be implemented using some complex programming. So it requires more complex programming, which is also one of the disadvantage of isolated IO. Next, moving on to the memory mapped IO. Advantages of memory mapped IO. The advantage of memory mapped IO is faster IO operations, because both the memory space and address space is common. So it can be, then the instructions can be executed, IO operations can be done much faster compared to your isolated IO, and simplified programming. You does not require any complex instructions to be implemented in order to implement the concept of memory mapped IO. So the instructions are very simple and they take very less amount of time to execute compared to your isolated IO. And efficient use of memory space. So you are sharing the same memory space with memory as well as IO devices. So you are effectively making use of a memory space, not wasting any of the memory space. So efficient usage of memory space. So these are the advantages of memory mapped IO. So this is about input output interface. Next, moving on to the asynchronous data transfer. So there are actually two types of, whenever you take a source and a destination, whenever the information has to be moved from the source to the destination, it can be mainly done in two ways, synchronous and asynchronous operations. So first we will see what is the difference between the synchronous and asynchronous operation, then we move on to the asynchronous data transfer. Synchronous operation is nothing but it is a transmission, it is a type of transmission in which a common clock pulse, if you take a source and a destination, whenever an information has to be transferred from source to destination, in case of a synchronous transmission, the clock pulse, the same common clock pulse will be applied between the source machine as well as the destination machine in case of a synchronous transmission. In case of an asynchronous transmission, it is a type of transmission in which the sender process and the receiver process will have their own clock, and that does not require any external clock to be implemented in order to take care of the timing signals. So, next because of, as I already told you, because of the differences between the CPU and the IO devices, you cannot implement the synchronous transmission or synchronous communication between the CPU and IO. So, we move on with asynchronous data transfer. So, with asynchronous data transfer is nothing but it requires two independent units that requires they are going to transfer some control signals between them in order to transfer the data. Before transferring the data, some control signals are being transferred between the source and the destination in order to implement the effective communication between the source and the destination. And in case of asynchronous data transfer, this can be implemented in two ways. The first method is using a strobe mechanism and the second method is using a handshaking mechanism. So, you can implement asynchronous data transfer where the sender clock and the receiver clock, they are having their own clocks to take care of the data transmission, and that type of transmission is said to be called as asynchronous data transfer, and that can be implemented using two mechanisms called strobe and handshaking mechanisms. Next we will see what is a strobe control mechanism or strobe mechanism. Strobe control method is nothing but it is one of the method of asynchronous data transfer which uses a single signal called as a strobe signal in order to transfer the data between the source machine as well as source and the destination, or between the sender and the receiver. So, this particular strobe signal, it can be activated by either the source unit or the destination unit. Anyone can send the strobe signal, and that is again classified based on the who is going to activate the strobe signal. So, if it is done by the source, it is called as a source initiated strobe, and if the strobe signal is generated by the destination unit, it is called as a destination initiated strobe. So, we will see what is the difference between a source initiated strobe and destination initiated strobe. So, in case if you see the block diagram of source initiated strobe, this is a source unit and the destination unit. So, in case of a source initiated strobe, before actually the source sending a data to the destination, it will first generate a strobe signal and send it to the destination unit. And this strobe signal indicates that the source unit is ready for sending a data. So, it is intimating the destination unit that the strobe is going to send the data to the destination, and immediately after sending a strobe signal, the source unit will place the data on the data bus. So, if you see the timing diagram for the source initiated data transfer, first the particular strobe signal will be sent and then the data signal will be sent. So, what that this strobe signal indicate the destination unit that the whatever data is placed on the data bus, that is a valid data, and the data is sent by the source validated authorized source unit. So, this is the timing diagram. Next, coming to the destination initiated strobe for data transfer. Here you have a source unit and the destination unit, and before the actual data transfer take place, as the name indicates, the destination initiated strobe. So, the destination unit is going to send a strobe signal to the source. This signal indicates that the destination unit is ready to receive the data. So, the source unit will then place a data on the data bus so that the destination unit will receive the data. So, in the case of its timing diagram, first the destination is sending a strobe signal, and immediately the source is going to place a data on the data bus so that the destination will receive the data. Next, coming to the disadvantages of a strobe mechanism. In case of a source initiated strobe mechanism, the source unit initiate the transfer and it will send a strobe signal, it will places the data on the data bus, but it does not know whether the data is exactly received by the destination unit or not. So that is one of a disadvantage of source initiated strobing mechanism. Next, coming to the destination initiated strobing mechanism, the destination unit initiates the transfer and it does not know whether it will send a strobe signal to the sender, but it does not know whether the data has been placed on the data bus or not until it receives the data from the source. So these are the two advantages of source initiated strobe mechanism and destination initiated strobe mechanism. So because of these disadvantages of strobe control mechanism, we go for the next type of asynchronous data transfer mechanism, which is called as a handshaking mechanism. So in case of a handshaking mechanism, this mechanism introduces a second control signal, and that signal acts as a reply at the destination side, reply to the unit that initiates the transfer. So whenever a sender is sending a message, an additional signal will be sent from the destination to the source that indicates that it is an acknowledgement from the receiver that the message is received by the receiver. It is acknowledgement to the source unit. So we will see it. So this handshaking mechanism can also be implemented in two ways. One is a source initiated handshaking mechanism and other one is a destination initiated handshaking mechanism. So this is a source initiated handshaking mechanism. So here we have a source unit and the destination unit. So what the source unit will do here is it will place an information or a data on the data bus, and then it will enable the data valid signal. So this data valid signal means that a valid information is placed on the data bus to the destination unit, and after the destination unit receives the data which is placed on the data bus, it will send a data accepted signal. So this data accepted signal provides an information to the source that the information has been received by the destination successfully. So if you see the timing diagram of a source initiated handshaking mechanism, the source will place the data on the data bus and it sends a data valid signal, and the data will be, after some time the destination unit is accepting the data, and then it will send a data accepted line back to the source unit after some amount of time. So when it receives the data accepted line, the source unit will disable the data valid signal. So the information which is present on the bus will be invalidated. So next, coming to the destination initiated handshaking mechanism. Next. So if you see this diagram, it will explain you clearly about what is happening as in the source initiated handshaking. The source will place the data on the data bus and it will enable the data valid signal, and the destination unit will accept the data from the bus and it will enable the data accepted line. So this data accepted line will be sent to the sender. Whenever the source unit receives the data accepted line, it will disable the data valid signal so that it invalidates the information or the data which is placed on the bus. So and then the receiver will disable the data accepted line which is already sent to the source unit, so that now it is again ready to accept the new data. Next, coming to the destination initiated handshaking mechanism. So in the case, as the name implies, destination initiated handshaking. So before the actual data transfer takes place, the destination unit is initiating the transfer of data by sending a ready for data signal to the source unit. So once the destination unit sends a ready for data signal to the source unit, the source will place a data on the data bus. So first the destination is sending a ready for data signal, then immediately the data will be placed on the data bus by the source unit. So data bus, and it places a valid data on the data bus. So if you go to the next diagram, it will clearly explain you what is happening. So it places, the source unit places a data on the bus and it will enable the data valid line. First the destination is sending the ready to accept data signal to the source unit and it will enable the ready for data line. So whenever the source unit receives the ready to accept data, the source unit places the data on the data bus and it will enable the data valid line. And next it accepts, the destination units accept the data which is placed on the data bus and it will disable the ready for data which is previously enabled. So whenever it disables the ready for data, the resource unit, whenever it sees the disable of ready for data, it will disable the data valid line, so that the information which is on the placed on the bus by the source unit will be disabled. So next, coming to the asynchronous serial transfer, coming to the asynchronous communication, it can be basically done in two ways: asynchronous parallel transfer and asynchronous serial transfer. In case of asynchronous parallel transfer, more bits are information or the bits are transferred in a parallel manner between the sender process and the receiver process. But here, since there are so many differences between the CPU and the IO devices, asynchronous parallel transfer is not possible in case of an input-output organization. So we go for implementing an asynchronous serial transfer mechanism in order to transfer the information between the IO devices and the CPU. And the rules for transmission in case of a serial transfer is nothing but whenever any character or any information, in case of a serial transfer, the information is transferred in the form of one character at a time. One character is nothing but one ASCII character is represented by means of 8 bits. So between each and every character, the character when you are starting before, whenever the sender process is idle, it will be represented by 1, and whenever it starts transferring the characters, it starts with the start bit, and the end of that particular character, it ends with the stop bits. So the start bits start with 0 and the stop bits will end with 1 or double 1. It can be either 1 or 1 1. So if whenever a character is being transferred, it will start with a stop bit of 0. Whenever it is stop bit, it will be a downward pulse, and this is actually a data, 8-bit data that has to be transferred, which is represented by one character, and then whenever the character ends, it is ended with a stop bit. Stop bit here, it can be a 1 or it can be a 1 1. So between a start bit and stop bit, your actual information or a character is being transferred in case of a serial communication. So whenever a character is not being sent, the line is kept in a 1 state, which means here idle state. When no information is sent, it will be in an idle state. The initiation of a character transmission is detected from a start bit, which is always 0. It starts transmitting the data with a start bit of 0, followed by the character bits, which are 8-bit representation of the ASCII value, and after the last bit of the character is transmitted, a stop bit is detected, and this stop bit can be either a 1 or a 1 1. So this is how asynchronous serial transfer takes place between any two communication interfaces. Next, you can implement that asynchronous serial transfer by means of an asynchronous communication interface. So that particular transmission of the data can be implemented by using an asynchronous communication interface between your sender process and the receiver process. So if you see this diagram, we have an internal bus, and there are this is a timing and control unit which have chip selection input and register select input and read and write inputs of timing and control. Along with this, we have an internal bus, and we have a transmitter register, receiver register, and control register and status register. So whenever an information has to be transferred from this transmitter to the receiver, the information from the bus is first transferred into the transmitter register, and from the transmitter register it is sent into the shift register, which stores the data, and before transferring the data to the receiver register. At the receiver side, that information will be received and first kept in the receiver shift register of the receiver, and then transmitted to the receiver register. So other than this, we also have a control register and a status register, and the control register is used to find what type of operation we are performing, whether it is a read operation or a write operation. Apart from this, a control register is also used to find out is there any parity bits in your data, or what is the number of bits that are represented in each character, and other information such as what are the number of stop bits, whether we are taking a stop bit as single 1 or 1 1. So depending, all the information will be placed in the control register. So next comes the status register, and this status register is going to check the status of your IO device, whether it is idle or it is busy, that particular information, and it also acts as it can also be used in order to find out any errors during the transmission process. That information is also being recorded in the status register. So in the transmitter side we have a transmitter clock and the receiver side we have a receiver clock. Since as I already told you, it is an asynchronous communication interface where the transmitter and the receiver will have their own clock pulses, own clocks present. And if you see the timing diagram for this, based on the chip selection input and register select input, we are going to identify what type of an operation we are going to perform and what is the register which is selected in order to perform the particular operation. So in case of a chip selection input is 0 and if register select is a don't care, none of the register is being selected, none of the operations will be done on any of the registers, no operations will be done. So in case of your chip selection, whenever your chip selection input is 1 and your register select input is 0, in that case we are going to perform a write operation, and that particular write operation is being performed in the transmitter register. So the information from the bus is written into the transmitter register by enabling the write operation on the transmitter register. Similarly, whenever the chip selection input is CS is 1 and register select is 1. So if both are 1 1, we are going to perform a write operation, and that write operation is done using on the control register. So if you identify this, these two are inputs, so the data from the bus will be copied into the corresponding registers, and if you identify these two registers, these have an output arrow which indicates that we are going to read the information from the corresponding registers onto the bus. So if it is 1 1, you are performing a write operation into the control register, and if it is 1 0, chip selection is 1 and RS is 0, in that case we are performing a read operation from the receiver register. The data present in the receiver register is read into the bus. In case of 1 1, if it is 1 1, in that case we are performing a read operation in the status register. Whatever the status information which is present in the status register regarding the status of the IO device or regarding the errors in the transmission, that information is read onto the IO bus. So this is the timing diagram for this particular asynchronous communication interface. Depending upon the chip selection inputs and register select input, it specifies the operation that has to be done, as well as on which register the particular operation will be done is based on the timing diagram. So with this we have completed asynchronous communication interface.